Subnet Mask. Think of the subnet mask as the invisible divider that defines the boundaries of every single network in existence. In the world of IPv4, an IP address is not just a random string of numbers. It is a two-part identity, much like a person's full name or a physical mailing address. The subnet mask is the mathematical tool that tells the computer exactly where the network ID, the street name, ends, and where the host ID, the house number, begins. Without a subnet mask, a computer would have no idea who is a neighbor in the same room and who is a stranger on the other side of the planet. For a cybersecurity professional, mastering the mask is the first step in understanding how we isolate systems and secure data. The binary logic, ones and zeros. To understand the mask, you must look past the decimal numbers like 255.255.0.0 and look at the binary code underneath. Every IP address and every subnet mask is exactly 32 bits long, divided into 4 groups called octets. The rules of the subnet mask are strict and simple. Wherever there is a binary 1 in the mask, that corresponding bit in the IP address belongs to the network. Wherever there is a binary 0 in the mask, that corresponding bit belongs to the individual host. Because a 255 in decimal is equal to 8 binary ones, a mask of 255.255.255.0 tells the computer that the first 24 bits of the address are the street name, leaving only the last 8 bits for house numbers. Why we subnet, performance and security. You might wonder, why not just put everyone on one massive network? The answer lies in the problem of broadcast traffic. In an Ethernet network, computers frequently shout to find things, such as a printer or a DHCP server. This is called a broadcast. If you had 10,000 computers on one single network, the noise from all those simultaneous shouts would be so overwhelming that the actual data wouldn't be able to get through. This is known as a broadcast storm. By using a subnet mask to create smaller, isolated subnets, an administrator can contain that noise. It's like putting walls in a large building to create separate offices. The people in the accounting office can shout to find their printer without bothering the people in the human resources office. From a security perspective, this is even more critical. By placing sensitive servers on their own subnet with a specific mask, you can use a firewall or a gateway to control exactly who is allowed to cross the boundary into that high-security zone. CIDR notation, the shorthand of the professionals. In your studies at BCC and for your CompTIA A+, you will often see the subnet mask written in a shorthand called CIDR, or Classless Interdomain Routing Notation. This is written as a slash followed by a number, such as 24. This number simply tells you how many ones are in the mask. A 8255000 means only the first octet is the network. This provides over 16 million addresses. A 1625525500 means the first 2 octets are the network. This provides over 65,000 addresses. A 242552552550 is the most common for small businesses, providing 254 usable host addresses. The non-usable addresses, network and broadcast. When you apply a subnet mask to a range of numbers, there are always 2 specific addresses in that range that you are strictly forbidden from assigning to a laptop or a server. The first is the network ID. This is the very first address in the subnet, where all the host bits are zeros. It acts as the street sign for the entire group. Routers use this address in their routing tables to know where to send traffic. The second is the broadcast address. This is the very last address in the subnet, where all the host bits are ones. If a computer wants to send a message to every single device on its local subnet, it sends the data to this specific number. This is why, in a 24 subnet which has 256 total numbers, you only have 254 usable slots for your actual devices. Troubleshooting the off-by-one mask error. As a network technician, an incorrect subnet mask is one of the most sneaky and difficult problems to diagnose. It doesn't usually cause a complete disconnect. Instead, it causes partial connectivity. If a computer has a mask that is too wide, it might think a server in the next building is actually in the same room, instead of sending the data to the default gateway. It tries to talk to the server directly. The server never hears the request, and the user just sees a connection timed out error. Conversely, if the mask is too narrow, the computer might think its own neighbor is a stranger and try to send local traffic to the router, which the router will then drop. Always remember, the IP address is the destination, but the subnet mask is the map used to get there. Without the correct map, you are wandering in the dark.